Let's talk about estimating sums using the alternating series test. So just as we saw when learning about the integral test, we can estimate the sum S of a convergence series with the nth partial sum. Now, again, whenever you're doing any sort of an estimation, you always worry about the amount of error. So our concern is to bound the amount of error in our estimate. And we have a theorem. Our theorem is the alternating series estimation theorem. And basically, if we call S equal to the actual sum of the series, where each of those Bn terms are greater than 0, the sum of all the alternating series satisfies the following two conditions. We need that the limit as n goes to infinity of Bn is equal to 0, and we also need that Bn plus 1 is less than or equal to Bn. In other words, these are the very two conditions we have for the alternating series. So when we have, for the alternating series test, So when we have those two conditions satisfied, in other words, we know that the alternating series converges, then we can bound the error. So I'm going to call Rn the amount of error in the right tail, and that is going to equal to, if we took the sum of the series minus the sum of the first n terms, and we took the absolute value of that, that's really what our Rn means. And this is going to be less than or equal to the Bn plus 1 term. Okay, so just to make it perfectly clear, this S minus Sn, this is that infinite tail as I goes from n plus 1 to infinity of our alternating series AI. So this S is our sum, just to be perfectly clear. This Sn is the sum of the first n terms as I goes from 1 to n of the AI, and those are alternating. And then this difference between those in absolute value, that's the infinite tail. So this is the infinite tail, which is also the error. Okay. All right, everyone. I'm going to show you an example in class. I'll probably use technology to help us bound the error term. So we'll just keep this video short. Take care, everyone.